Alright, so keep in mind, when you're adding, subtracting, you're just counting. And when you're counting how many of each kind of variable. So you're counting here how many m's there are and how many m squared. And you'll never combine, that's why I'm color coding them. You're never going to add an m with an m squared. You're going to count how many m squareds there are and how many m's there are. Sometimes we'll be subtracting, you'll have to do a little distributive, but other than that, not bad. So how many m's do you have here? Knowing that this is 1. We have 1 m here and 5 more here. Altogether you have 6 m. And we have 1 m squared here and 6 more here. So altogether you have 7 m squared here. I'm just counting how many of each do you have. In general, though, you want to be your answer in descending order. So highest exponent first. So just flip those around, make it 7m squared plus 6. So as you're doing this, start with the highest exponent, write it down, and then the next highest exponent, write it down, and then your answer will automatically be in this order, descending order. Descending means to count down, and counting down the exponent value. Like number 3, we have a subtraction, so we'll have to distribute first. Here I just kind of added, addition. I just counted right away, but here it's subtraction. So probably a good idea just to rewrite it. Keep the first one the same. And then here make sure you subtract 4 and subtract 3, 8, 4. Identify what you can combine. So we have k to the 4th, and we have regular numbers. Regular numbers are like 0. So we're always going exponent order. So numbers, think of them as 0, so no matter what, the numbers will always be last. So we're going to start with doing this, seeing what that equals, and then we'll do the numbers last. So how many k to the 4ths are there? Yeah. 5 minus 3, 2k to the 4th. And then regular numbers, you got a 2 and a minus 4. Minus 2. And you see how it's already in descending order because they started with the highest exponent first. So just think of adding, subtracting always as counting. How many of each thing do you have? In real life, it'd be more like, we're counting 2 different things, apples and oranges. It doesn't matter if we call them k to the 4th and n to the 2nd. Just think of those 2 different things that are unrelated. Why don't you guys try 5? Give it a shot, see what you get. This is an addition one, so it's a little bit faster. Have negative 3x to the 4th and 1x to the 4th. Have an x and negative 7x. And then we'll have just a positive 7 at the end. So there's no other numbers, so I know it'll just be a plus 7 at the end. So think of this in like a color-coded way. Before you start, visually see, okay, I can combine these 2 together, then these 2 together, and then here's a 7, there's no other numbers, so there's going to be a plus 7 at the end. Have that planned before you start. It'll make things easier and avoid more mistakes. So again, negative 3 plus 1. Negative 3. And we have 1 and negative 7. 6. plus 7x. And since I started on the highest exponent first and went down, my answer is already in percent order. So this might seem simple. Yeah, you're just adding, subtracting, but you'd be surprised how many small mistakes you can do. The number one mistake I would say is not realizing that this is a negative 7x. People see like, okay, that's 1x, here's a 7x, okay, that's 8x. So include the subtraction sign and think of it as a negative sign. That's a negative 7x, not just 7x. Anything else? About how simple. So subtraction, go ahead and write out the first polynomial. Do you guys remember, what is it called when you have 3 terms in a polynomial?
Binomial?
Binomial. And 2 terms. Binomial, 1 term would be a monomial. If there are no terms, well, it's nothing. If there's more than 3 terms, it's just a polynomial. So we have minus 8b to the third, don't forget to distribute, plus 2b to the fourth, plus 4b. Go ahead, and since you guys don't have colors, only you have pencils there, you can do different types of underline. You say, before you start doing anything, underline those because they both have a b to the third, and you can like say, I'm going to put a box around these, so you just have another way of marking what goes together. Say, put a square around those, and put a circle around the b's. Just some notation that shows these 2 things go together. So I know the underlines go together, the circles go together, the squares go together. So we have negative, we're going to start with the fourth, that's the highest power. What is negative 2 plus
0?
You got 0. And then to the b's, what is 4 minus 4?
0.
And what is 8 minus 8?
0.
So 0 plus 0 plus 0. 0. I really want to do this problem just to highlight the idea that things can cancel out. So just because you start with a b to the fourth doesn't mean there'll be a b to the fourth in your answer. It can happen equals 0. So that should keep you good on the front. Go to the next one. Here. There we go. 3 directions. Factor each polynomial below. Product of its greatest monomial factor and another polynomial. Basically, find the g-squared. Write your answer, find your answer, and notice the letter next to it. Write this letter in each box that contains another answer. So what is the biggest number that goes into 3, 18, 9?
18.
Biggest number that goes into all 3.
18.
3 is the biggest number that goes into 3, 18, and 9. And you know the answers are down here. So what's left inside? So 3 times what is 3x squared?
X squared.
So we're going to do in reverse distributive property. Instead of multiplying the 3 in, I'm dividing it out. So reverse of distributive property. So think of 18 divided by 3. 6 x. And 9 divided by 3. 3. And if you want to check your work, you can always redistribute it mentally. Say, okay, that checks out. Okay, that's 18x. Okay, that's 9. That equals this. If these are equal, then you're done. And we can find that down here. Which one is it? A. That's number 1. Go down here, under 1. So you'll see, remember it said to take out the greatest binomial factor and another polynomial. So these are all these right here are the greatest binomial factors, also known as GCF. That's the biggest number that goes into the sum of these. Some of these you can see 7 goes in all these numbers, 2 goes in all these numbers, and so on. Over here you're going to see, well, what else do they have in common besides numbers? They also have variables. Since there's an n in all of them, you can take out that. So here, you see, well, all these have an n, you can take out an n. And then again, work backwards, divide. This is what you guys did yesterday. So n times what is n to the third? Squared. Remember to add the exponents. This is like a 1. So that would make 3. N to the what times n is n to the second. And n to the what?
0. Or nothing.
1. N times 1 is n. And then you find that below. So 6 happens to also be an A. And lastly, third column, you look at the answers, you see you can have a number and a variable. So the first column, we just took out a number. Second column, you can see it's mostly just variables, but there's also some numbers too to take out. The third column is about putting them together and taking out both. So what number goes into 4 and 32? 4. 34. And they both have something, a variable in common, which is k. You can take out a 4 and a k. And work backwards. 4k times what is 4k to the third?
K
Squared. And 4k times what is negative 32k?
Negative 8.
You know it's negative, and then 4 times 8 is negative 32. That's 11. For 11, we'll put G. So we're going to start off where you can actually check to make sure your answer's down here. That way if there's any mistake with a variable or something, you'll catch it. But of course, eventually you're not going to have a list of choose from. This is more of the same. There's just going to be multiple variables. So, like here you can see, find a good one. Like on 10, last side, you can see they have a 3 in common. A 3 goes into both of them. These both have an A. There's an A squared and an A here. So I have an A in common. And they also have a B to the second. This has a B to the second. This has a B to the third. So they at least both have a B to the second. So you can have many different terms as a GCF. So what's missing? We got a 3a at b to the second, and this is going to be 3a to the second b to the second. See that? And this is only missing an a. This a times a would be a squared. Everything will be 3 times what is 15? A times what is A? 1. And b squared times what is b to the third? And you get b. So 11. right here. And if all else fails, you can just distribute this and see what it matches here. So keep in mind of all this stuff, you're just doing the reverse of distributive property. That's something you started in the 7th grade. So there's just a lot more stuff. But the algebra is identical. So M, okay, 11 is M. And it looks like there's 2 11s here, 3 11s. Well, we could plan there. Do you need to do any more, or is that good enough?
More.
Yes, no? Yeah, sounds like, looks like a lot of you guys are already working. So,
Sure.
let you guys keep on going then.